Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about ideal characteristics of op-amp. Op-amp has several ideal characteristics. So first one is open loop voltage gain. So first we should know what is open loop. So open loop is nothing but the gain of the op-amp when it is not having any feedback. So when there is a feedback from the output to the input, then it is known as closed loop. So here it is an open loop voltage gain. So ideally an op-amp should have an infinite open loop gain. Practically, it is hundreds of thousands of times larger than the potential difference between its input terminals. Next one is the input impedance, or you can say input resistance. So ideally, the op-amp should have infinite input impedance or resistance, but practically the input impedance should be very high. Next one is output impedance or resistance. So ideally for an op-amp, it should have zero output resistance, uh, but practically the output resistance should be very low. Next one is the noise distribution. So the noise contribution here it should be zero so that the output will be better. And next one is the DC output offset. It is also should be zero for an ideal op-amp. Next one is bandwidth. So ideally for an op-amp, it should be infinite bandwidth, but practically it is limited. Next one is CMRR, which is known as common mode rejection ratio. So common mode rejection ratio is nothing but the ability of the op-amp to reject the common mode signals and to allow the differential mode signal. So the CMRR should be infinite for an ideal op-amp. It is given by ratio of the differential mode gain to the common mode gain. Mm, since it is infinite, it will provide common noise voltage in the output will be zero. The next one is slew rate. Slew rate is nothing but the how fast the op amp achieves its final value. It is determined by the slew rate. So the op amp should attain its final value very fast. That there should not be any delay. So the slew rate should be infinite for an ideal op amp. So that any change in the input voltage simultaneously changes the output voltage also. So these are the ideal characteristics of op-amp. So let us see each one in detail. So an ideal op-amp is an op-amp that has perfect conditions to allow it to function as an op-amp with 100% efficiency. First one is the open loop voltage gain. So it's a gain of the op-amp without any feedback. The feedback can be two types, positive or negative feedback. If there is feedback, it is then said to be closed loop. Here you will not have any feedback. So for an ideal op amp, it should be infinite, but typical values ranges from 20,000 to 200,000 in real devices. Next one is infinite input impedance. So input impedance is nothing but the ratio of the input voltage to the input current, which is given by V in by I in. So this should be infinite. So the input current will be equal to zero. So high grade op amps can have input impedance in the range of tera ohms range. Low grade op amps will have milliamp input currents. Next one is zero output impedance. So the ideal op amp acts as a perfect internal voltage source with no internal resistance. So this internal resistance is in series with the load, reducing the output voltage available to the load. So the range here for the output impedance is 120 ohms. Mm, Next one is zero noise contribution. So in ideal op amps, the zero noise voltage is produced internally. This is any noise at the output must have been at the input as well. So practical op amps are affected by several noise sources such as resistive and semiconductor noise. So these effects can have considerable effects in low signal level applications. Next one is zero DC output offset. So the output offset is the output voltage of an amplifier when both the inputs are grounded. So the ideal op amp has zero output offset, but real op amps have some amount of output offset voltage. Next one is infinite bandwidth. So the ideal op amp will amplify all the signals from DC to the highest AC frequency. So when the bandwidth is infinite, it will allow all the frequencies. But real op amps, the bandwidth will be limited by the gain bandwidth product, which is equal to the frequency where the amplifier gain becomes unity. For the IC741, it is limited up to few kilohertz. Before going into some assessment, we'll see few advantages of op amp. So the compactness of the op amp is a very beneficial characteristics since it allows integration of op amp in larger circuits, and it's a versatile device, and it's very simple to use, and it's cheap and pocket friendly device, as well as it can easily be used in simulation circuits since they can be easily programmed to create circuits at a professional level. Some of the disadvantages are it becomes difficult to implement the circuit when the circuit level increases. A good understanding of the concept is required to create these complex circuits. And the need for some symmetrical power distribution across the input terminals is a major requirement for op amps, and also it's useful only for low frequency appliances, and it cannot handle high power since they can get destroyed due to the high power. Op amps have a slow response time. Let us take up some assessment questions. Which of the following electrical characteristics is not exhibited by an ideal op amp? The options are infinite voltage gain, infinite bandwidth, infinite output resistance, and infinite slew rate. So you know that the output resistance should be zero. So the answer here is infinite output resistance. The next one is an ideal op amp requires infinite bandwidth because the options are signals can be amplified without attenuation, output common mode noise voltage is zero, output voltage occurs simultaneously with the input voltage changes, output can drive infinite number of devices. Yes, the answer here is signals can be amplified without attenuation. Next one is ideal op amp has infinite voltage gain because the options are to control the output voltage, to obtain finite output voltage, to receive zero noise output voltage, and none of the above. The answer here is to obtain finite output voltage. Thank you for watching this video.